Okay, good morning everyone. Did I turn on the mic? Okay, good morning everyone. Can you hear my voice again?
Yes, doctor. Yes,
Okay.
doctor.
So we will start with continue with the last class where we have discussed this question. Okay, if you remember. So here, this question is like it's already given uh, the critical temperatures, but still from the question we try to find again. We analysis last time. We try to find the what is the T min and T max. Actually, if you see the full question, you can see, but even without looking at the T question, we supposedly know how to calculate the T min and T max. Okay, based on what to call this minimum voltage produced over here, we actually can find the minimum temperature for the instrument. Okay, and then based on the reference voltage given here, and also the what to call this RF and RI, okay, you actually can find the maximum input voltage for this instrument. Okay, so V2 actually we can find, so this is actually V2, and from V2 you actually can find the T max. So that is actually what we did in the last class, where we find the T min and T max, minimum temperature and maximum temperature for this instrument. Okay, and yes, we later then we check with the question. Yeah, that's actually correct, the minimum and then the maximum temperature. Okay, then we actually continued with what to call that, for example, let's say the voltage over here is actually 1.54, determine V2. What will be the V2 means the input voltage here, V out here 1.5, and then what should be the V2 over here. So we just tried with one scenario just like that, where we find the what is that output voltage should be V 1.5 over here, and then V2 we find based on the equation. So then V2 actually we find as 0.4 voltage. Okay, 0.4 voltage, and what should be the temperature at that time means you have to 0.4 divided by 20 milli, you will get the temperature. Okay, we continue with the temperature. So this is actually the V2, right? What is the V2 and what is the temperature means? What would be the temperature at this V2? Okay, how to calculate? Use the what to call the transfer function of this sensor. Okay, so V equals to T times 20 millivolt per. Just we start with the basic again lah, just to recall. T equals to V equals to V equals to T times 20 millivolt per degree Celsius, right? Okay, so here we have what is the T? We don't know the T, we know the V. So T would be 0.4 divided by 20 milli. What is the answer? What is the answer?
20.
20. So 20 degrees Celsius. Okay, if this is the case. Okay, 20 is actually within this range. Yeah, makes sense. Okay, so from here to here, or from here to here, you should supposed to know what is actually going on and how to calculate each and everything. Okay, this is actually like an analyze, it's not a design question. Okay, then before we go to the ADC equation actually here, later we go to the ADC. I just want to further go into what to call that, on this part, on this where you will program your before you go to the programming, you have to prepare the data and then model the equation, the correct equation, so that you can get the right output. Usually what students do, you remember from the lab view, from what you call from the LVs, you record the data over A naught, correct or not? So A naught actually will what you call not record the measure data from the A naught pin, analog pin, and that particular value actually directly will be shown in your lab view. ADC actually done by itself, automatically done by itself, and then it will be directly showing your what is that, the voltage, okay, particular voltage from this lab view, LVs, A naught pin, A naught or A1, like any analog pin. Okay, what is the you know what is the voltage range for A naught in lab view? In this is actually related to your mini project, you know. In lab view, A naught vary from where to where? From what voltage to minimum voltage would be what?
0,
0 to
12,
12, huh? I got lah.
15,
No. A naught is actually the IO pin on your board.
5,
5. Tembak sajalah. Any value. Last kena one. Okay, IO usually either it's actually work on 3.3 or 5. I think LabVIEW actually 5 would. Okay. LabVIEW 5. Some of the IO actually work with a 3.3. Okay. So for this case actually 0 to 5. Not exactly 5 plus actually 4 point. Theoretically should be 5. Okay. So this is actually will be shown in your lab view later. Okay, when from your if you read the data from pin A naught, you will see this value directly, which means the ADC already done. Okay, the ADC already done by this lab view itself. It directly show the 0 to 5. If you use like what to call normal embedded board like microcontroller like Arduino, okay, you won't have this value directly. You will have what to call that either you can read it as a decimal value of the ADC, or you will have what to call that binary value of the or hex value of the ADC. Okay, but LabVIEW it doesn't show like that. It directly give you the voltage. So once you have this voltage over here, you see, now you have the voltage, correct or not? Now you have this voltage from here to here. Okay, but let's say you want to display the temperature. Okay, now we read the temperature. For example, let's say I read 20 degrees Celsius from the sensor. Okay, I hope you understand what I'm trying to say here. Okay, this is your LVs. And then you have your, for example, let's say LM35. Signal conditioning. Then you connect to where? Pin A naught. Okay, this is your amplifier lah. You connect to the pin A naught. Then in your piece, in your computer lab view, when you read the A naught, okay, using what you call DAQ assistant, right? Yeah, DAQ assistant. When you read through the value, okay, you actually will read from, this is actually it capable to read the value from 0 to 5 volt. Okay, the A naught. But if it is a microcontroller, it is not 0 to 5. It's actually in hex value from 0 to 255. Okay, 0 to FF or 0 to 255 in decimal. Okay, you will read like that in microcontroller. So LabVIEW directly will show this value. Later you will see. If you haven't noticed, later when you're doing the mini project, you will see. Okay, this is actually representing the whole what to call that ADC system actually. So it's already done everything here in the LabVIEW software itself. So now you want to display this one in the value. Okay, you want to display this value. If you display this value in LabVIEW, the temperature, what you will, if you directly display this, what you will display, you will display the value from 0 to 5. Correct or not? You not actually produce the value from 0 to 5 means if you display directly, you will get 0 to 5 only. But let's say you want to translate back, because you want to show that 0.1 means it's actually refer to some temperature. Correct or not? What is the temperature? So display temperature means you have to display the temperature, not the voltage. Correct or not? So what are you supposed to do before you display it? What are you supposed to do with that voltage over here?
Process.
Process. Yeah, process. So you have to create an equation. Okay. Oh, your morning class actually, I mean the 8 a.m. class face to face.
Yes.
PT
Yeah.
all. PT all. So some that's why actually less student over here. 113. Okay. Mesti kelas busu just now. Kesian you all. Okay, 0 to 5. So you have to process it. Okay, you have to create an equation so that it can show the temperature. Usually student actually they lost here. Okay, they have 0 to 5 and then they create their own equation lah. Okay, times 20 times 10, so that they actually have like something like what to call that, can it shows like some, what to say, closely related to the temperature value lah. Makes sense. Okay, any sensible value, if they see means, then they say okay. So they try and error with this 0 to 5, we multiply with this. But that's actually not the right, not the accurate, I mean the right way to do. So supposedly you have to create the equation over here. So you have like this, the temperature actually become like your, I mean this 0 to 5 actually will become like a x. Okay, and then you should have your temperature. For example, let's say this 0 to 5 actually become like a x. Then you should have an equation over here before you display it. Okay, so so what should be the equation according to this question? If you see, according to the question, this works actually from 14 to 22. Okay, the 14 to 22 actually will represent the 0 to 5 over here. Okay, so here you have 14 to 22, correct or not? Here you have like 14 degrees Celsius, 22, right? Yeah, 22. 14 degrees Celsius to 22 degrees Celsius. So this will become your input, and then the output is actually over here, is actually 0 to 5. Okay, that actually produced over here actually 0 to 5. 0 to 5 volt. And again you have the 0 to 5 here, correct or not? What you should get? The 0 refer to what? 14 and 5 should be 22. So you will create the equation over here. Okay, equation over here. Can you create the equation based on these two data, 0 to 5 and then 14 to 22? Can you try first? This is actually normal mathematics. Can you get the equation? T equals to, in terms of x, actually what? T equals to x plus something. Can you get the equation? Boleh tak boleh?
Tak boleh.
Tak boleh. Ni cakap pandai. Tapi tak boleh. Normal linear equation lah you see if you have like you produce some graph like this 0 to 5, this is x lah, and this is t. So t is actually from 14 to 22. Okay, at this time is actually x is what, 0, and at 5 actually 22. Okay, now can you create the equation for this line?
Boleh.
Y equals to mx plus c. Create the equation. Try first. What is the equation?
1.6x
1.6x 1.6x plus
14.
14. Okay, so this is actually like a very basic where you have what to call, you have to find the gradient, correct or not, m. So this one divided by this one, right? So you'll have the difference over here is actually 18, right? 22. The m equals to 22 minus 14 over 50. So here you'll have 8 over 5, which is 1.6. Okay, and then this is actually the c is actually 14. So you should have t equals to 1.6 plus 14. So supposedly you should have this equation, don't times multiply with what to call 10, 15 or 25, so that you get like some temperature. It's actually not accurate. So if you multiply like this, then you will get exactly, for example, let's say you're reading 14, you will get it show 14. If you read 22, it will show 22. Okay, in one final exam, I ask question like this. I just give 4 marks lah. Nobody answer in the final exam. Okay, just try it once, and then after that I never give. Okay, so this is what you're supposed to do. This is actually linear, but if it is a what to call like non-linear equation, you have to translate in terms of the log. Okay, like NTC, they have like one equation, I forgot the name. Okay, but still, at least because we have like very narrow temperature, right? You still can assume narrow, I mean linear lah, if you want. It's not so accurate for NTC, but still better than you just multiply with 10 or 15 or anything. Okay, any questions so far for this?
No.
So don't ask again during the mini project time, I mean the lab time. I think next year lah, probably we will go to the lab, because next week I don't believe most of you actually will come back for the lab. Monday we have a holiday. Okay, then Tuesday will be missing, and Thursday you might want to extend the leave. Okay, so we cannot see many students in the lab, but if you're already there, we will check your how you going to do the mini project. Okay, And again, don't ask me the same question again, how to translate. So I already teach. Then you have to put your own effort, right? Actually, this is no need to be taught in for your mini project. Suppose you can find by yourself. Okay, then so this is actually, you see lab view. This is actually the what happened with the lab view. Don't later confuse the lab view, because lab view directly do the ADC by itself. Okay, the LVs with the lab view directly do the ADC by itself, and then the DO key assistant will produce the 0 to 5. What voltage actually it exactly measured here, it actually will show here, unlike other what to call microcontroller or microprocessor board. Okay, now we go to this question again. So this question, this is actually very simple and direct question. I teach you many things from this question. Hope you understand what actually going on. So this is actually what I asked you just now, what we did here. Model a suitable equation that can translate x input the t, okay, t output. So this is what I exactly done here. Okay, and we go to the ADC now, analog to digital converter. Okay, so in this question we this is actually like general question. Even without lab you will have like a ADC there. Okay, most of the ADC actually now not external. Last time you have to buy the ADC separately. Last time your microcontroller, it only can read digital values. Okay, yeah, not digital. Yes, it won't have analog pin last time. Initial microcontroller microprocessor. So you will buy the ADC separately and do the additional work. So that's why ADC actually important now. But now everything actually internally done ADC. Okay. So but still you need to know what's actually going on inside the ADC. So this is actually the equation that actually give the code of the output code of the ADC. Okay, because ADC, if you see here, you will have like a, in terms of voltage, here you have voltage. This voltage actually will be translated to the 8-bit system, so that your computer or microcontroller can process the data. Because you know, right, I mean the computer or microcontroller, they only deal with the bits, I mean like what to call the binary or hex lah, correct or not? All the machine actually understand that bits only. So that's why we have to change it. Okay, so that is the reason we want to find the output code, and this is actually the equation for this ADC, where you will have the V in of the ADC, which is actually V out of the signal conditioning, V in of the ADC, and then the reference voltage 2 volt, and then the bit system. How many bit system? This is actually how many bit? 8 bit. Okay, if they put the cross like this and then put 8, means this is actually n equals to 8. This 8 is actually n equals to 8. Okay, then once you have this, you actually can calculate the output code. So for example, let's say we have like for this question we have determined the ADC output for each critical temperature. What are the critical temperature? 14, 19 and 22. So we start with 14. Output code, this is actually for 14 lah, 14 degrees Celsius. What should be the value over here? B in, B ref actually 22. This is 2 power of 8 minus 1, 255 later. What should be the V in over here?
Should be 0.
Why it is actually 0? It's not 14 times
Because
this
we
one.
do signal conditioning.
Supposedly 14 times 20 millivolt, right? 14 times 20 millivolt, you'll have like a 0.28, right? Why suddenly you seeing 0? It is 0 or 0.28? Hello? Anyone else? It is 0 or 0.28?
0.28.
0.28. The rest? Who actually tell me that this is actually 0? Siapa tu? Scared already. Anyone else
I
actually
think
saying that this is actually 0? Yep.
I think 0 because we do signal conditioning before enter the ADC.
Yep. So this is actually 0. I just want to confuse you, It's not 0.2, it's actually 0 because this data actually over here, the B in, it is not from the output over here. This is actually after the signal conditioning. So after the signal conditioning, we have 0 to 5. So 14 means, as for the signal conditioning, this is actually 0. 14 degrees Celsius means, okay, for the signal conditioning, it is actually 0. It's actually not 0.28. So usually students actually do the mistake. 14 means they take this 0.28 and then put here. No, not correct. So for this case, this is actually output code will be 0, or you can write 0, 0, 0, 0, 0, 0, 0, or you can write 0, 0. I mean in hex lah, this is actually in hex. This is actually in decimal, this is actually in binary. And for, what is the next temperature? 19. 19 degrees Celsius, the output code would be, what is the value over here? Times 255. What is the V in value for this one? 19, we did for 19 or not? No. Did we do for 19? No, right? Haven't done for 19. So you have to do 19. Actually got quite some work to be done as for the 19. Okay, get V out of signal conditioning for this first. V out of signal conditioning. That actually become the V in for this ADC. No? So you have to do this one first. Try to do first. I give you 5 minutes. What is the value? After signal conditioning, what should be the value for 19?
Um, 0.38.
0.38. It's not after signal conditioning. 0.38 is actually after the after what you
No,
call
no, 228.
0.28. Cannot be
Uh-huh.
0.28. I think should be higher than that. Okay, should be near to 1 point something. Okay, so this is actually for V out at transducer. Transducer, you will have 19 times 20 milli, correct or not? So this is actually 0.38, right? Okay, then to find the V out after the signal conditioning, you will use this equation. Remember this equation. So V2 minus 0.28, the minimum voltage is 0.28 times RF over RI. RF over RI, what is that value? 12.5, but I think better start from the beginning. 125 over 10. 125 over 10, which will give 12.5. So what is the V2 over here? 0.38. 0.28 times 12.5. Is it 1.25? At signal conditioning. 1.25, right? Anyone get 1.25?
Correct.
Okay. Dia cakap correct. Saya student. Dia lecturer dah. Good if you can get 1.25. So here you supposedly substitute 1.25. Okay, don't directly put 0.38 here. Finish actually. So you see, it looks like very simple, determine the ADC output for each critical temperature, but when you deal with it, it will take some work and then some time. Okay, don't get too excited. Oh, very easy, just use this equation and then do some mistake, finish. So what should be the value over here? 1.25 divided by 159.38. Okay, so for the sake of simplicity, just what is that, round off this number, easier. Okay, round off this number, but actually, I mean, for this case you cannot use, you will use 1.15, round off 159, right? 159. But actually, if you use this equation, let's say even you have like a 159.6, you'll choose 159, but I don't want to confuse you over there. Just choose 159. Output code. Let's say the question asks you in terms of binary or hexa, you should change. So in terms of 159, in terms of binary what and hexa what? Anyone try to get?
In hexa is 9F.
In hexa is actually 9F. Okay. This is in hexa. In binary, 1111. 9 is what? Forgot already.
1001.
1001. Okay, this is actually in binary. If they ask in this form. Okay, so if you use microcontroller, you should know how to deal with it. Okay, microcontroller or microprocessor embedded, I believe have done before, right? Microcontroller embedded next sem, I think. Okay. Yes, so that's actually for 19 degree Celsius. You see 19 actually got so many work to do to be done. And for one more critical temperature actually 22 degrees Celsius. At 22 degrees Celsius, output code is actually what?
FF.
FF. So you no need to calculate actually. Okay, but if you want to calculate, this will be 2 over 2. Output code actually will be 2 over 2 times 2 n something ready, 2 n minus 1. So you will have 255 in decimal, and this is which means FF in hexa or 1111 in binary. Okay, so apart from this minimum and maximum, they ask any value means you have to do this the whole thing. Okay, from sensors and then sensor to signal conditioning, then only from signal conditioning to the ADC value, ADC output code. Find interesting or not interesting, very boring or confusing?
Interesting.
Interesting. Who actually find very difficult? Honestly, tell me. Anyone find very difficult or confusing? All good? Okay, so later in final or in final, don't do funny mistakes all. Okay, try to do it properly. Okay, still in this question, if you want to play around, let's say if what to call that, the output code actually already given here. Okay, output code already given here, and then they ask the temperature, means you know how to do, right? For example, let's say I give like output code of which is 3A, for example. Okay, 3A in hexa. So 3A, you know how to change it to temperature, right? Can or cannot? Boleh buat tak boleh buat?
Can.
So hope you can do lah actually if it is asked like that. If you already model the equation, okay, if you already model the equation, it's easier. But you won't model the equation if it didn't ask in the exam. So what you will do, you will go in reverse way. So from this output code, you will find the input, and from the input you will find this V2, and from the V2 you will find the temperature. Okay, so many works, it's actually not easy. So I think we can try. So let's say we have a lot of let's say in this question. All the let's say actually can become your question in your final exam, or any of it lah. Let's say output code is 3A hexa. Determine the measured temperature. Can or not? Boleh buat? Try. I give you 10 minutes for this one because got a lot of work to do.
Is it 0.063 Celsius?
0.063
63.
Celsius. Cannot be. Can
15.8.
15.8.
15.8.
Because you see, the range actually from 14 to 22, correct or not? So 14 to 22. So 14 to 22 means you should get the value from here. No? If you get below than the operating range, then something wrong. Either you, I don't know what mistake you did, but it's actually wrong. 0.063. Oh, this is actually the voltage. The voltage also not 0.03, right? Voltage actually from 0.28 to 0.38. It's on wrong, something wrong here. Some wrong thing actually happened over here. Okay, 3AH in decimal is actually what?
58.
3A hexa in decimal actually 58.
58.
Okay, in decimal 58, because we have to use the decimal value over here. So the output code actually 58 equals to, we don't know the input voltage for the ADC, correct or not? The V in actually we don't know, and the reference voltage is actually 2 times with 255. Okay, and from here we can get the V in. What is the V in? 58 times 2 divided by
Oh,
22.
V in equals to 0.063.
0.063. So this value lah actually he got. Okay.
Oh, sorry.
Just now he got 0.063. Correct Okay. Betul kan? 0.063, right? Boleh percaya kan? Never mind, I calculate. Nobody actually answered.
Also not 0.063.
Wait.
0.45.
454, right? Hey, come on lah, baby. Who actually giving the wrong answer all the time? 0.454. Correct or not? 0.455
Yes.
actually, sorry. Okay. Hey, please calculate properly. Don't do mistakes, silly mistakes all. 0.455, which is actually at this place, right? 0.455 after the signal conditioning, or before the ADC. And now we want to get the V2. To get the V2, so this is actually the output voltage of the ADC. 0.455 equals to V2 minus 0.28 times with, is it 15.12.5? What is the V2 now? 0.455
0.3164.
Okay, 0.3164. This is actually the voltage of produced by the sensor over here, V2. Okay, and now we want to get the temperature. The temperature equals to 0.316 divided by the divide by the 20 milli. 4 divided by the 20 milli. What is the answer? You should get. That's not what you said, I forgot it. 15.8 degrees Celsius. Okay, so you should know. So you see the question maybe looks like a simple or difficult, whatever it is. So you should know what you're supposed to do. Okay, don't give me panic attack. Usually student, even though I teach the ADC and DAC, later I'll teach the DAC in depth, but I always see the students still do the mistake over here, you know. They still take the wrong values. Sometimes they stop here. Okay. Sometimes they get this value and directly from this value they try to find the temperature. Okay, so cannot, you'll get a wrong answer actually. Okay. So do it carefully. Do it carefully. Do it in a very systematic way later. Any questions so far? Anyone cannot answer any part? Boleh ya, semua boleh.
Boleh.
Yang lain? Tak apa, sekarang saya tanya seorang.
Boleh ke?
Boleh ya. Only 118. Very less students lah actually. Another 40 actually missing. Just imagine this 40 students lah. They miss here. Miss the class over here. And maybe they become your your team member in your mini project. They'll kill you. And yeah, they also will be suiciding themselves during the final exam. Any question? Okay, no question. So I believe for today this is actually sufficient. Okay, this is sufficient for today. If no further question, I will stop because I don't want to add on more chapters because we actually